Hello, Algebra 2. Welcome to Chapter 7. In Chapter 7, we will do a lot with exponential equations and functions, specifically when there is a variable in the exponent. So that's what's going to be kind of crazy today. We start with graphing, and of course with graphing I'm going to see, like I said, variables in the exponent, as you can see there with this x right there. When it says b, you should know that b is a number. But notice it has a rule. B is going to be bigger than 1. And actually the rule is that b, this is for exponential growth. So this is where you can see the graph is growing. It's going up. We're also going to have exponential decay. And that's where it'll look like that. So really what you want to know, trying to look ahead. Okay, so we do decay down there. So we'll check that out later. For growth, though, b is always going to be bigger than 1. So, the domain is going to be all reals. It can go all the way to left and right. There is going to be something called an asymptote here. I think we've talked about these before, but basically there's going to be a value in which the graph cannot get any lower. In a very boring parent function, that line will be 0. So as you notice, it kind of appears to be touching this line, but it never intercepts it. And it's never going to cross it. So that's your asymptote there. It'll never go lower. And the reason is, it doesn't matter what exponent you give a number, it's never going to go into the negatives, right? Because if you use a positive exponent, like 2 squared, that becomes 4, 2 cubed is 8. The numbers just keep getting bigger. The bigger positive exponent you have, your number gets bigger. But now if you give it a negative exponent, so like if I do my 2 to the negative second, well, that just turns it into 1 over 2 squared, which is just, it's supposed to be an arrow, 1/4, which is still a positive number. And it doesn't matter how big I make that exponent, it just makes it a smaller and smaller decimal. So that's why it never crosses the line. Of course, it never just stays in the same boring spot. It can move up, down, stretch, compress, flip, left, right, all that good stuff. You might notice some of our old friends, A, H, and K. Here's what you should know about these. K will move the asymptote. So as I'm looking at 2a, you see this -5 here? That means the asymptote is actually going to be down here at -5. 1, 2, 3, 4, 5. So on this line, the graph is going to approach, but never cross that line. Okay, so the directions are graph this. I say graph, you say table. And you can use a graphing calculator to get the table if you'd like. Or if you are familiar with Desmos, you can use that. Here's the generic kind of what this table looks like at -4. It's -4.5. -3 is -4. -2 is -3. -1 is -1. 0 is 3. 1 is 11. And I'll do -5. It's -4.75. I do have mine plugged into my calculator, so as I scroll up, I can see, even up at like -10, I'm at -4.99. And so it never actually approaches 5, and it's never going to cross it. So if I go ahead and graph that, -5, 1, 2, 3, 4, 5, really close to the line. It's hard to draw with this pen, but you can imagine where it is. This is 4.5. This is 4. Where am I at? -2, -3, -1. Ooh, look, we got quite some growth going on here. Okay, and as I look ahead on the calculator, it gets really close to the asymptote, but it never actually crosses. And then you just want to connect the dots in as smooth of a curve as possible. And if the directions say to find the domain, that's just going to be all reals. It's always all reals. Domain, all reals. The range Okay, it's kind of unclear because on here it just says all positive numbers, but that's because the asymptote was at 0. Your range is going to be y is greater than the k value here. Okay, y is bigger than the asymptote. This time the asymptote is 5. That means range is y is greater than 5. Notice it does not actually equal 5. Decay is pretty much the exact same. What you should notice is different is that this time b is going to be between 0 and 1. Notice we never have a negative base value. It's always positive. But if it's between 0 and 1, it is going to cause our graph to go down. And I say graph, you say table. You're probably good on that. If you're using the black calculators to get the table, just make sure you put the x minus 4 in parentheses. All right, I'm going to do 2 videos for this section, so I'm going to pause there, and we'll pick back up on example 3 in a minute.